Hello, this is the second video in the ship stability analysis. In this video we will be discussing misconception and making the ship stability more sciencey. What is the misconception about stability? The first that comes to mind is the rotation point. There is a lot of people who have different point of view on this thing, and we want to make sure that it's really clear. And the second thing that we want to do, we want to dimensionalize the equation and the results and find a way of using it in a more professional way. What is the rotation point? What people perceive? Some people believe the rotation is in the gravity centroid, some people believe it's in the buoyancy centroid, and some people believe it's in the meta center. In the next clip you will see somebody, a professor, who believes that the rotation it's around the meta center.
Transverse stability. I want to illustrate something called the metacenter. So you take the ship, right, and tip it over a little bit, and a little bit more, and a little bit more, and a little bit more. You can see that B here is the original center of buoyancy. It's shifting over to this B prime here. Okay, you keep going, keep going. It turns out that the ship for small angles sort of follows a circle, and the middle of the circle is M. It's called the transverse metacenter. This is not a point that is actually on the ship. You don't build it. It is just a property of the ship. So it is an imaginary point way up high.
After we hear this clip that claiming that the rotation is around the meta center, let's take it seriously and analyze it. There are basically three different zones where the rotation will be, and they depend on the cross area when around the water line or water level. If around the water level the cross area is constant or the derivative is zero, the rotation point is fixed and it's around point A. If the derivative is positive, that means the cross area increases with the height. The rotation area moves to the left, and vice versa. If the cross area reduces with the height, it will move to the right. And what I mean by that? Let's look on typical area. If we're looking on this one, that's a extruded rectangle that we always like to discuss. And we have our regular gravity center, buoyancy center, and the meta center. The rotation will be around point A, not M, but point A. And the reason for this is geometrical, because the area on the right and the area on the left have to be the same. The weight of the ship does not change during the rotation, and the same amount of volume that we are displacing has to be the same before and after. So what we add and what we subtract have to be the same, and therefore it must be around point A or at point A. If we take a extruded rectangle, that the area going up or the cross area increasing with the rectangle, we can see immediately in order to keep the area constant, the rotation will move to point A to the left, and the more we rotate, the more it will move to the left, and vice versa on the other side. The more we rotate on cross area on rectangle, that the area going down will move to the right. Now, to explain a little bit more the point that's move, it's the same thing like we have a stick on a circle. When the stick move, the contact area always move with this, so it's basically the same situation. The rotation area, it's not fixed, it's moving the same way with the stick. In the case of the triangle or the area that is changing, it's moving with the thing, movement, with the angle of the rotation. The second point that we want to talk about is the dimensionless. This was a big thing, and there was big fights about it. My advisor changed the heat transfer and he checked non-dimensionalized. And people in the beginning said that what he done is basically nonsense. Today there is no place on Earth, well, except a certain area in mass transfer that is not heat transfer, they're still using dimensional presentation. It's kind of strange to see in 2021 in ship stability, which is really a lot of people in different departments all around the country, they're still using dimensional presentation. It's mind-boggling. It's bizarre, to say the least, that it's still used. Basically, we should use non-dimensional presentation, that we can collapse the information in such a way that we can extend maximum utility to it. This has to be ratio of the density versus the width to the height, or similar dimension of the ship, and we can draw the stability diagram. We can talk about stability area that is stable and area that is, actually this is unstable, and area that is stable. It's outside that. We have the maximum, actually it's the minimum point of the stability. Okay, let's summarize this presentation. We talk about rotation point. We make it clear that the misconception so prevailing in the field that it's has to change, and we have to talk about the dimensionalization of the equation and the results. We have to make it more sciencey, presented today world. It's a must. I hope you enjoy the video. Please click if you like, subscribe to the channel, and come to hear the next video. Thank you and have a nice day.